Hello, everyone. So this is another question, again on hypothesis testing and using the Z distribution. Now, in this one, we do have our mu to be 40. Our standard deviation is 8. Our N is given a sample of 98. Our X bar is 42.2. Our significance level alpha is 0.01. Now, what are we testing for? We are testing for a single mean. That's the first question. The second question, I know you don't see it, but the second question is, what is the level of significance? And that is alpha, which is 0.01. Now, how do we set up our hypothesis testing, or how do we set up our null hypotheses and alternative hypotheses? So how do we do that? So HO is going to be mu equals 40. And then our HA or H1 is going to be mu. Here it says more than, so greater than 40. So that's what you have here. Now, if you want to draw, because we're going to use a standard normal, if you want to draw the standard normal curve, because this is more than, you're going to have that and then probably put it here. So this becomes your rejection region. And here you have your 0.01, which is your significance level. Okay. Now, if you want to use, if you have to find the p-value, because some of the problems want the p-value, to find the p-value again, find your test statistic, which is your z. So we're going to do that. So z equals x bar, and I showed you this formula in class, so I'm going to do 42.2 minus 40 over our standard deviation, which is 8 divided by the square root of n, which is 98. And then you solve for that. So this should give us, let me check. This should give us, so you have that, 42.2, oops, minus 40 divided by 8 divided by the square root of n, which is 98. So I have 2.722, so remember it's z, so you do 2 decimal places, 2.72. Now to find your p-value, use the test statistic. To find your p-value, use the test statistic. And then go to your table and then find the area. So 2.72, find that area. It's 0.9967. But remember, this area is going to be to the right, right? It's going to be to the left. But the question says more than 40. So we are looking at to the right. So what you have to do is to subtract from 1. So for the p-value, you deal with it just like you deal with the area. So you're going to have 1 minus 0.99. What did I get? 0.9967, which gives us approximately 0.0033. So this becomes our p-value. This becomes our p-value. And then what do you do with the p-value? You compare the p-value to your alpha or your significance level. If the p-value is less than the alpha, you reject the null hypothesis. If the p-value is greater than the alpha, you accept the null hypothesis. Here it is less than the alpha, so we reject the null hypothesis, and then we give a conclusion based on that. Okay? Now, let's say that you have the option not to use the p-value, and we did that in class. So not to use the p-value. So what do? You have your test statistic, which is 2.72. So that is what you're going to use for the test. Now, your significance level, you already know that as 0.01. So you find this z value. To find the z value, go to the table. So we subtract from 1 because the table is always going to give you to the left, right? The area to the left. So we find 0.99 on the table. Where are you? 0.99. Yes, so you have 2.33. 2.33. Now, this 2.33, you're going to compare it with this. Now, 2.72 is greater. It's right here, 2.72. So you would see that 2.72 is in the rejection region. So we reject the null hypothesis. So using the p-value or just using the z like we did in class, it's the same thing. You're getting the same conclusion. But the thing is that if you are told to find the p-value, that's how you find it, the first one I did. Now, you have to recognize that when the alternative hypothesis is greater, we have to subtract from 1, right, to get the p-value. When you have HO to be mu equals 40, this is just an example. HA or H1 to be mu is not equal to 40. Then you have the same problem. You have a two-tailed, right? On the left, on the right. We talked about this in class, on the left and on the right. So in that case, to find the p-value, again, you deal with it just like you would deal with the z and then the area. So it's not equal to means it's two-tailed. So you divide the significance level by 2. And then if you find the area of this part right here with your z, to find your p-value, then you have to multiply by 2 because you just did one part, right? And it's the same. It's symmetric, so you multiply by 2. So same idea here, just like you would do with the area and the z, you do the same thing with the p-value. And what I mean, I think there was an example like that, so you know what I mean. And like we did in class, same ideas. You divide by 2, you multiply by 2 when you have one of them. So thank you. Bye.